All right, this video is on atomic orbitals and their energy values, ranking them, and then starting to talk about how the atomic orbitals are filled with electrons. Okay, so in a prior video or lecture, we learned about the fact that Schrodinger discovered these atomic orbitals. They're where the electrons live in an atom, and there are 4 types, and they have 4 different shapes. There's an s orbital, a p orbital, a d orbital, and an f orbital. We learned how we can correspond the s, the p, the d, and the f to the periodic table like I have pictured right here. Okay, we also learned that the periods of the periodic table are not only periods, but they're the energy levels, which from here on out is the most important thing to us. Okay, so this discussion is kind of on, well, what do these atomic orbitals look like in terms of their energy, and kind of ranking them in their energies before we specifically learn the rules for filling the orbitals and writing something called electron configurations. So if we go back up to my picture, I'm going to draw kind of an energy diagram, so to speak. So this is like a graph. Low energy at the bottom and high energy at the top. And so I'm going to start with the first orbital I would encounter. Okay, the lowest energy orbital, of course, is the 1s orbital, because that's the lowest energy level. So if you can remember about the s orbital, there's only one orientation. So I'm going to draw like a little line, and I'm going to label this as the 1s. Remember the notation of 1s. 1 is the energy level, and s is the shape of the orbital. So after the 1s, so the 1s is here and here, right? Then I'm forced to go to the 2s. Okay, well, the 2s is in the second energy level, which is slightly higher in energy than the 1s. So when I draw the 2s, I'm going to draw it at a higher energy, right? It's going up this graph. And following the 2s comes the 2p. Okay, now the 2p, you would think that it has the same energy as the 2s. Actually, it doesn't. It's at a slightly higher energy. And I just drew 3 lines, okay? And I wonder if you know why I drew 3 lines. And this was our discussion from before about the fact that there are 3 orientations for the p. Do you remember the px, the py, and the pz? Okay, that is why I drew 3 orientations, because this orbital can hold 2, this orbital can hold 2, and this orbital can hold 2 for a total of 6. Now that takes us through the second energy level. So then from there we go to the third with the 3s, which is going to be at a slightly higher energy. Why? Because it's in the third energy level, followed by the 3p. Okay. And then we come to the 4s, so it's going to be slightly higher in energy. And then we get to the 3, remember it's 3d, okay? And so the 3d is actually in the third energy level, okay? But the 4s and the 3d are so close in energy that's how come they appear to be switched on the periodic table. So, and then we could keep going, but I don't really want to, and plus I would run out of room eventually. But I want to draw your attention to something, and that is this. When you were in middle school, you had a teacher, I'm sure, who taught you that around the nucleus were energy levels, and the electrons orbited on those energy levels like the planets orbit the sun. And they taught you that each energy level held a certain number of electrons. And that in and of itself was not false. They just didn't teach you about orbitals because you weren't ready. But check this out. So look at this. And I'm going to kind of mark up my picture here, but that's okay because this is what I wanted to show you in this video. So in the first energy level, right, we've already said how many electrons could live in that 1s. There could be 2. So the first energy level holds 2 electrons. And that's what you were taught, even when you were taught that they were like orbits. The second energy level is comprised of not only the 2s, but also the 2p. And if you think about that, each one of those orbitals can hold 2 electrons. So 2 in the 2s and 6 in the 2p, the second energy level can hold a total of 8 electrons. If you think about the third energy level, okay, and each one of those orbitals can hold 2. So 2 in the 3s, 6 in the 3p, and 10 in the 3d. It's a total of 18. You may have had a teacher who taught you only 8, and that's because they were discounting the 3d from being in the third energy level, and there's a reason for that. So you were not like on purpose misled in this discussion. It was just that you were not exactly ready to have a discussion about orbitals when you first learned about electrons and where they lived. There's one other thing I want to teach you in this, so I'm going to erase my lines, and that is the fact that there's a word for the fact that, check this out. Do you see how the 2p orbitals, their energy value would reside right here, right, if I were to do this? And the 3p would reside here, and the 3d somewhere in here, okay? Well, all 3 of these orbitals have the same amount of energy. All 3 of these orbitals have the same amount of energy. And all 5 of those orbitals have the same amount of energy. Notice the 1s doesn't have the same amount of energy as anybody else, nor the 2s, the 3s, nor the 4s. So there's a word for this, and that word is degenerate. And to be degenerate means orbitals of equal energy. That's it. Okay, so in this case, the 2p that looks like this, and the 2p that looks like this, and the 2p that looks like this, all have the same energy, and they are said to be degenerate with each other.